Someone will please just confirm whether am I audible and my screen is visible.
Yes, ma'am.
Okay, thank you. So let's begin. So last time we just discussed about even and odd signals. So I will quickly summarize rest of the things and then we will move to problem solving. So we will start with conjugate symmetry and conjugate asymmetry. So now that you have watched the videos, will someone answer what is a conjugate symmetric signal? I am denoting it by CS here.
When the conjugate and the real function is same.
Yeah, so basically x of t is equal to x star of minus t. X star is the conjugation operation and minus t is the reversal. We can also write it as xt conjugate is equal to x of minus t. So when we talk about conjugate symmetric signals, conjugation is equal to time reversal. For conjugate symmetric signals, conjugation is equal to time reversal. And when we talk about conjugate asymmetric signals or skew symmetric signals, that is another name for them. Conjugate asymmetric signals or skew symmetric signals. For them, x of t is equal to minus x star of minus t, or we can write x star of t is equal to minus x of minus t. So when we talk about conjugate asymmetric signals, conjugation is equal to time and amplitude reversal. Conjugation is equal to time and amplitude reversal for conjugate asymmetric signals. Now, just like we decomposed a real signal xt into its even and odd parts, similarly, we can decompose any signal into its conjugate symmetric and conjugate asymmetric part. So, the decomposition will be x of t is equal to x conjugate of t plus x conjugate symmetric of t x conjugate asymmetric of t. If I have to write the expression for the conjugate symmetric part, it will be half xt plus x star minus t divided by 2. So this, you can notice the similarity between conjugate symmetric and even. So there it was xt plus x of minus t by 2 for the even part. So here we have this conjugation operation. Okay.
Okay, ma'am.
Now let us write the conjugate asymmetric part. That you can kind of relate with the odd signals. So it is almost similar except that there is this conjugation. So x conjugate asymmetric t signal is half xt minus x star of minus t. Now if I have a signal xt which is real, if xt is real, then conjugate symmetric, sorry, if a signal xt is real, then xt will be equal to its conjugate. So in this case, conjugate symmetric will become even, conjugate asymmetric will become odd. So now if you look at these expressions, if xt is real, x star of t will be equal to xt. If we replace it here, we will get the same thing that we had for even and odd. But in even and odd, it used to affect the area, but conjugate symmetric and conjugate asymmetric signals do not affect the area and neither the orthogonality, because conjugation operation is there, so we cannot directly say. So unlike even odd, conjugate symmetric, conjugate asymmetric does not affect area, and so orthogonality. As conjugation operation is there, now let us take a complex signal. For a complex signal xt, if it is a complex signal, it will have a real part and an imaginary part. So xr of t is its real part, xi of t is the imaginary part. Now when if xt is conjugate symmetric, then its real part of xt will be even and imaginary part will be odd. If xt is conjugate asymmetric, real part will be odd and imaginary part will be even. Is that fine?
Yes, ma'am.
All right, so now let us talk about the magnitude and phase. So irrespective of whether the signal is conjugate symmetric or conjugate asymmetric, magnitudes will always be even and phase will be something like tan inverse imaginary upon real. But since we have phase wrapping, so we cannot really talk about symmetry of a phase. You must have seen in the video, right?
Yes, ma'am.
Do you remember about the even odd signals when we discussed their multiplication and addition and how we consider even to be a positive and odd to be a negative number, and then we got these conclusions? Do you guys remember that?
Yes, ma'am.
So similarly, we can do that here also. So let us take two signals xt, yt, their product and their sum. So we have these two signals which are in general complex signals xt, yt. We are considering their product and their sum. So if xt is conjugate asymmetric, yt is conjugate symmetric. I will write that again here. So we can kind of consider, to remember this, conjugate symmetric to be a positive number, conjugate asymmetric to be a negative number. Of course, you can find it out just like we did and professor discussed, but this is kind of just to remember. So conjugate xt is conjugate asymmetric, yt is conjugate symmetric. So what will their product be? Can someone unmute and speak? Can someone please unmute and speak for the first case when xt is conjugate asymmetric, yt is conjugate symmetric?
Then it will be conjugate asymmetric.
Yes, the product will be conjugate asymmetric. How can we see that? This will be like kind of positive and this will be kind of like negative. Positive into negative will give me negative, so I will write conjugate asymmetric. Now when we talk about their sum, so when we add a positive and negative number, we do not know what it will be. So we do not know, it will be actually neither. So neither conjugate asymmetric nor conjugate symmetric. Now let us move to the second case when both xt and yt are conjugate symmetric.
Conjugate symmetric.
Yes. And the sum will also be conjugate symmetric. For the third case, conjugate symmetric, both are conjugate asymmetric.
Conjugate symmetric.
Yes. And the sum?
Conjugate asymmetric.
Yes. So when we multiply two negative numbers, we get a positive. So we can say conjugate symmetric. And when we add two negative numbers, we will get a negative number. So conjugate asymmetric. Now let us take one example. So I have this phasor or Euler signal e raised to the power of j omega t. So is it conjugate symmetric or is it conjugate asymmetric? Okay,
Conjugate asymmetric.
Let us see. We have xt is equal to e raised to the power of j omega t. Let us take the conjugation. When I conjugate e raised to the power of j omega t, j will turn into minus j. So the conjugate will be minus j omega t, right? Class, conjugate will be this. Is this fine?
Yes, ma'am, it will. It is.
Yes, so now we will take the reversal of the conjugate. Reversal t is replaced by minus t, so we get back e raised to the power of j omega t. What do we see? X of t is equal to x star of minus t. This is the condition for conjugate symmetric. So e raised to the power of j omega t is conjugate symmetric. Now, if we expand this Euler signal in terms of sine and cos, we will have cos omega t. Yes.
When we do this xt, after that we have to do the time reversal also.
When we talk about conjugate symmetric, so this is the condition xt is equal to x star of minus t.
Oh, okay.
So we have to do both conjugation and reversal. For skew symmetric or for conjugate asymmetric, we will do both conjugation and reversal, and then when we will get a negative sign also here. But here it will be equal.
Okay, got it.
In even odd, we just do time reversal, but for complex signals, conjugate symmetry, conjugate asymmetry, apart from time reversal, we also take conjugate.
Okay, got it.
Alright, so now let us come back to our Euler signal. Xt is equal to e raised to the power of j omega t. I can write it as cos omega t plus j sin omega t, right? Is this fine, class?
Yes, ma'am.
Yes, ma'am.
Okay,
According to
so
Euler's identity.
yes. So is cos omega t an even signal or an odd signal?
Cos is even and sin omega t is odd.
Yes, so this is even, this is odd. Even plus odd is neither even nor odd. So this Euler signal e raised to the power of j omega t is conjugate symmetric and neither even nor odd. Fine?
Yes, ma'am.
Okay, now let us take a few more examples. These are from lectures only. So when we have cos omega t, we just now discussed it is an even signal. Is it conjugate symmetric or is it conjugate asymmetric?
Symmetric.
What? Please speak again.
Conjugate symmetric.
Yes. So this is conjugate symmetric. Just like we discussed just now, few minutes back. If a signal is real, then conjugate symmetric and even are same, and odd and conjugate asymmetric are same. So cos omega t is even and conjugate symmetric.
Ma'am,
Yes.
means you are saying if the signal is real, then
Yes.
and if the xt is even, then it will be conjugate symmetric, and if it is odd, then it is conjugate asymmetric.
Yes.
Okay, got it.
Have you watched the videos? Week 3 videos?
Yeah, all the lectures.
Okay. So do you want me to discuss that how this even and conjugate symmetric
No,
become
no,
same?
I got it now.
Okay. Let us take another example. E raised to the power of j omega t square. So let us try and find out whether it is conjugate symmetric, asymmetric, or neither. Okay, first let us try to find out whether it is even or not. For even, the condition is x of t should be equal to x of minus t, right? This is x of t. If I want to find out x of minus t, I will replace t by minus t here, but it is a square, so I will get back the same signal. So we observe here that this is an even signal. Okay. Now let us try to find out about conjugate symmetry and asymmetry. It is a complex signal. I have my x of t. I will take conjugate x star of t. So e raised to the power of conjugation means j will turn negative minus j omega t square. Now I will do time reversal. So for time reversal, I will replace t by minus t, but it is square, so it will stay as it is. So this is it is not equal to x of t, nor it is equal to minus of that. So it is neither conjugate symmetric nor conjugate asymmetric. Is this clear? Is there any confusion?
No, ma'am.
All right. Just for the sake of completion, I will write this. Anyways, I've written it, so let's skip it. So this is not equal to x of t, nor it is equal to minus x of t. So it is neither conjugate symmetric nor conjugate asymmetric. Okay, now let us take one more example. We have to sketch real and imaginary and magnitude and phase plot for this signal e raised to the power of sigma t plus j omega t. Sigma is real and sigma is also less than 0. So this has been given to us. Have you seen this in the lecture? Do you remember?
Yes, ma'am.
Okay, so first let me expand this quickly. Let's do it. E raised to the power of sigma t into e raised to the power of j omega t. Then we will break it down in terms of sine and cos. And this is what we will get once we multiply. Now this e raised to the power of sigma t, sigma is real. It is less than 0. So it will be a decaying exponential. Something like this. And so e raised to the power of sigma t is neither even nor odd, right?
Yes, ma'am.
Now we look at the real part of our signal, which is this. We have cosine multiplied by this decaying exponential. So cosine will kind of decrease, right? So I will draw it here. If it is too small, tell me, I will draw it below. So this is the real part. This is cosine, so it has to be like this. and then it will decay. So this is the real part. Now if we look at the imaginary part, it is sigma e raised to the power of sigma t decaying exponential, but we have sine. So it will be a decaying sine. So sine is like this, decaying, and on the negative side, because the amplitude is increasing. So we have drawn the real and imaginary parts. Now let us draw the magnitude and phase plots. So for my signal, which is this, magnitude is this part, e raised to the power of sigma t, and phase will be j omega, phase will be omega t, right? Let us draw it. Magnitude of xt is e raised to the power of sigma t, just the decaying exponential. Phase of xt is omega t. So we will draw it something like this, and then phase wrapping will occur. So something like this. Okay, is this fine?
Yes, ma'am.
Okay, now let us move to the next property.
In that lecture, sir made one sawtooth type graph.
Yeah, that is what is phase wrapping.
Can you explain that?
Phase wrapping.
Yes, ma'am.
Okay.
It was a bit confusing.
So when we talk about tan inverse, so what happens is omega t will this okay. This is my exponential e raised to the power of j omega t. If I do e raised to the power of j omega t plus 2 pi, so will I get back the same signal?
Yes, ma'am.
Yes, ma'am.
So that is what is essentially used in phase wrapping. So like for this interval, it will be like this, then it will go down again to this negative value, and it will repeat. Basically this periodicity thing comes here.
Oh, okay, ma'am. Got it.
Okay, so let us move to the next topic, periodic signals or the periodicity property. So what is a periodic signal? If we have any signal xt, which is equal to x of t plus capital T, where capital T is positive. So basically, if the signal repeats after a certain interval, then that signal is known as periodic. Also, if my signal is repeating after a certain interval, so it has to lie between minus infinity to infinity. Only then it will be periodic. Otherwise, if it stops at some point and we go back and add the period, then we will not get back the same signal. So when we talk about periodic signals, we have something called fundamental period. So fundamental period is actually the smallest value of this t above that we talked, which satisfies this condition, and this t has to be less than infinity. If my t is a period or a fundamental period, then n into t will also be the periods of repetition. Like for cos and sine, if it repeats after 2 pi, it also repeats after 4 pi, and so on. So these are also periods of repetition. N here is an integer. It can be plus minus 1, plus minus 2, plus minus 3, and so on. So what are periodic signals? That is, everyone is clear with that?
Yes, ma'am.
Yes, ma'am. It's clear.
All right, so now let us talk about area of a periodic signal. We have a property for the periodic signals. So if my xt is a periodic signal and I am calculating area from any constant a plus nt, t is the period, n is integer, and I calculate the area, let b be another constant. So the interval in both of these cases is nt. So area in any interval of same width will be same. I will just write it down. Area in any interval of width nt is same. So if it is a time period or integer multiple of time period, and in that width we calculate the area, that will be same. Okay, is that fine?
Yes, ma'am.
Okay, so now the next thing is aperiodic signal. What is a aperiodic signal? It is a signal whose values do not repeat at any interval. Aperiodic signal is a signal whose values do not repeat at any interval. So all finite length signals are aperiodic. Is that fine, or is there any confusion in this?
It's fine.
Okay. All finite length signals are aperiodic. But practically we have finite length signals only, right?
Yes, ma'am.
So practically all signals are finite length. So what we do is we calculate the periodicity in our time window of interest. Analytically, periodic signals should extend from minus infinity to infinity, just like we said in the beginning. For periodic signals, but in real life we do have finite length sequence, so they should be aperiodic. So what we do is we measure periodicity within our time window of interest. Is this fine?
Yes, ma'am.
In real life we measure periodicity within, do you guys make notes along with me? What about others?
What did you say, ma'am?
Do you make notes along with me of what I write here, or you don't?
Ma'am, I make notes of lectures.
Okay. So in real life, we measure periodicity within our time window of interest. Now, let us talk about combination of periodic signals. So let us say I have a signal xt. I have another signal yt. Xt and yt are periodic signals. The period of xt is t1. The period of y2 is t2. Now I have a signal zt, which is their sum, or it can also be equal to their product. So in both these cases, this sum or this product will be periodic if T1 by T2 will be rational. If it is irrational, then this sum or product is not periodic. And if it is rational, it is periodic, and period will be LCM of T1 and T2. If I have 5 signals, then all of their ratio should be rational, and then the period will be LCM of all of them. So you do not have to like suppose there are 5 signals, so you do not have to calculate like T1 by T2, then T1 by T3, then again T2 by T3. No, you do not have to do that. You suppose just take, you just suppose you took T1, so you will do T2 by T1, T3 by T1, T4 by T1, T5 by T1. If all of them are rational, then the period will be LCM of T1, T2, T3, T4, T5. Is this fine?
So ma'am, we
Yes,
will
ma'am.
just divide it.
Yes, Ananya?
So ma'am, we will just divide it by one period, and if they
Yes.
are rational, then we'll take LCM, and whatever we will get as LCM, that we will divide it by.
Yeah, so we will take one period and then others, and it has to be rational.
Okay, ma'am, can you show one example of it?
I don't actually have any example with me right now.
It's okay.
In practice questions, I have signals, but I think I have not taken more than 2.
Okay.
Let us take one example involving 2 signals. So I have sine t plus cos pi t. Can someone tell me the period of sine t?
2 pi.
2 pi.
Yes, correct. 2 pi divided by 1, 2 pi. What about cos pi t? What is the period?
2.
2.
Yes, 2 pi divided by pi, so it is 2. Now I calculate T2 by T1. This is sine signal is T1, cos is T2. 2 divided by 2 pi, is it rational?
Irrational.
So a number is rational if their ratio is integer and the denominator is not equal to 0. So here pi is irrational. So that means this signal is not periodic. Now let us take another example. E raised to the power of minus j 3t plus tan 2t. Can someone tell me the period of the first signal?
2 pi by 3.
Yes, 2 pi by 3, because in Euler signal this is omega. And what about tan 2t?
It will be pi.
2 pi divided by 2 pi. Now let us calculate. You can calculate anything. T1 by T2, T2 by T1. Let us calculate T2 by T1. So pi divided by 2 pi by 3. So we get 3 by 2. Is it rational?
Yes, ma'am.
Okay, now it is rational. Now that means this is periodic. So if it is periodic, we want to find out its period. So using this equation, this one, we can say the period will be 2 times T2 or 3 times T1, right? Is that fine?
Yes.
So we
Yes,
can
ma'am.
use either of them, and we will have our period to be 2 pi. Fine. All right. Now I want to give you another thing. So DC term is
Can you explain? I think I am little bit confusing.
which one? This one?
Uh, for, you have written t is equals to 2 pi, and you have set to t is equals to 2t2. Okay. Okay, got it. I am putting the wrong value.
Fine now.
Yes, ma'am, it is fine.
Okay. So DC term is always periodic with any arbitrary period. And also DC term does not affect periodicity. So what is a DC term? If this is my time axis, then DC term is like some constant, say 5, or you can say any constant A. So DC term is a constant from minus infinity to infinity. So if we encounter something like this, then it is periodic, but we cannot define its period. So we say DC term is always periodic with any arbitrary period. And the second term, DC term, does not affect periodicity. So if I add a cosine with a DC term, then it will still be periodic and the period will be of that cosine signal. Is that fine?
Yes, ma'am.
Okay, now let us move to time scaling and shifting of periodic signals. So does time shifting affect periodicity?
No,
Yes. So time shifting does not affect periodicity. What about time scaling?
it will affect.
Yes. Time shifting does not, but time scaling changes the period. So if I have a signal xt with a period of t, and then I do this time scaling, then my period will become t by mod a. If mod a is less than 1, period will increase. If mod a is greater than 1, period will decrease. Is that fine?
Yes, ma'am.
Okay, now I will give you an example, a signal, and you have to tell me whether it is periodic or aperiodic. Rect T, is it periodic or aperiodic?
Aperiodic.
Yes, this is my rect T. It is 1 between minus half to 1 and then outside 0. So it does not repeat. So it is aperiodic. Now if I take this signal, sigma n is equal to minus infinity to infinity, rect of t minus nt. T is a constant and I am giving it that t is greater than or equal to length of my finite length signal, which in this case is rect of t. So here t will be greater than or equal to 1. Will this be periodic?
Yes, I think.
Yes, yes, it will be periodic. I will draw it for you. So let us put n is equal to 0. When I put n equal to 0, I get rect t, right? Now I will draw rect t. So this is rect of t. Now let me put n is equal to 1. If I put n equal to 1, I will get rect of small t minus capital T, right?
Yes, ma'am.
Now rect of small t minus capital T means this signal rect of t has shifted to right by t, right?
Yes, ma'am.
So now I will have this, it will be centered at t. If I put, if I take n is equal to minus 1, I will get rect of t plus capital T. So now it will move t units to the left. So this is my signal and it will keep on repeating like this. So the period is this length t. So this is periodic signal. Is this clear?
Yes,
Yes,
ma'am.
ma'am.
All right. So I told you that t is greater than or equal to length of finite length signal. What if t is less than this length? What will happen?
Then the signal will become compiled, or it will take common part.
Yeah, I mean
Um,
some changes will happen, but my signal will still be periodic with a different period.
Yes, ma'am.
Okay, let's move ahead. Now, energy of signals. Let us talk about energy of signals, okay? So, when we want to compute energy of a signal, then this is the formula that we use. Suppose we are calculating energy of a signal X. So, it is we take the modulus of the signal, square it, and then integrate it from minus infinity to infinity. So this is the formula for the energy of the signal, right?
Yes, ma'am.
Okay, so if we have any signal whose energy is less than infinity, we call it to be an energy signal. So an energy signal is a signal whose energy is less than infinity. Is it fine?
Yes, ma'am. What? Why we are taking this XT?
Uh, I did not get your question.
Uh, like whenever we will do power into time, then we'll get energy. So how this XT square is power here?
It is not power here, it is energy.
So ma'am, like we just have the graph. Give me a minute, ma'am.
Sorry, please repeat.
So we have in this graph we have t and xt. So how this xt is after taking the area of xt we are getting energy? What's
No,
the
no, no.
relation?
We are not taking the area of xt. We are taking the magnitude of xt and then squaring it and then integrating from minus infinity to infinity.
So ma'am, what's the relation that I didn't get?
Basically, ma'am, she is asking how this expression is a energy of a signal. How we, from where we get this.
Well, I don't know the answer of this question. Maybe I can tell you next time. But
or
for now,
or 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 why we are doing for this energy of signal xt modulus square, why this one is, why not different one? That is the question, I think.
well, I don't know the answer right now. I will search about it or ask the professor and then get back to you. But for now, you can treat this as a formula that this is the formula by which we calculate the energy of the signal. If it is a complex signal, we will take its magnitude, square it, integrate from minus infinity to infinity. If it is a real signal, we will just square it and find the integration from minus infinity to infinity.
Okay, ma'am.
Now suppose I have a signal X with energy Ex and another signal which is minus of X. So if we compute the energy of E of X and E of minus X, it will not be equal to energy of X minus X. If we do X minus X, we will get 0. So energy of, when we compute energy of 0, it will come out to be 0. So this is not true. But when we talk about orthogonal signals, then we have this formula. So energy of orthogonal signals. Suppose we have one signal xt, another signal yt. We square it. We are finding the energy of their sum. So we can expand it in the following way. First mod of xt, next mod of yt square. Then we will have this dot product x star t dt from minus infinity to infinity plus xt y star t dt from minus infinity to infinity. So if we expand these signals, this is what we will get. Do you remember the definition of orthogonality of signals? Others remember the definition of orthogonality? Yeah, so if my signals xt and yt are orthogonal to each other, then by definition of orthogonality, these two terms will go to 0. So if these go to 0, then what I have is E of x plus y, energy of x plus y is equal to energy of x plus energy of y. So this expression is only true when x and y are orthogonal to each other. Okay, now let us compute energy of one signal. We have to find energy of triangular function. So let us write the triangular function. Do you remember doing this in the lecture? So do you want me to compute it or should I just leave it?
Leave it, and or you can take another signal, for example, which is not done in the lecture. It
That I
definitely.
have in the problem solving thing. This is just the summary for the lecture.
Okay.
So I will just quickly tell you how to do it. This is my triangular signal. This point over here is 0, comma 1. This over here is minus 1, comma 0. This over here is 1, comma 0. So this is one straight line. This is another straight line. We know 2 points, so we can write their equation. We will write their equation. So this side will come out to be 1 plus t. This side will come out to be 1 minus t. We will use the energy formula. So also I would like to emphasize one more thing. So left hand side plus the right hand side. Also, will you tell me whether this right and left parts are orthogonal to each other or not?
It is auto.
Yes, so they are orthogonal. And also, since it is a symmetrical figure, so energy for this part will be equal to the energy of this part. So when you compute this, you will get 1 by 3 for the left hand side and 1 by 3 for the right hand side, and this is the energy that we get. Now, let us take this signal. xt is equal to e raised to the power of minus t. So, will someone tell me what is the energy of this signal? Yes, class, what is the energy of xt is equal to e raised to the power of minus t?
1/2.
No, we are calculating energy. What we will do, this is a real signal. We will square it and do this integration. Now what will we get, Jay?
1/2, man.
Will we
Infinity.
get 1 by 2? Let us check there. Let us take the upper limit. So t is replaced by infinity. So e raised to the
Oh,
power of
okay,
minus
okay.
infinity will be
I didn't
0.
notice the limit.
Sorry. Jay, is it clear what will be the energy?
Yeah, ma'am. Ma'am, I got it. I am doing from 0 to 1. I didn't notice the limits minus infinity to infinity.
This is a different signal. Now the triangular signal is done.
Oh, okay.
So this e raised to the power of minus t extends from minus infinity to infinity. So we will get 0. So its energy is infinity. That means it is not an energy signal. What about xt is equal to 0? What is the energy of this signal?
It will stay 0.
Yes, the energy of this signal will be 0. Okay, if we have the any periodic signal, what will be their energy?
0.
Okay, let us do that again. So if I have a periodic signal, for example, this, so I will calculate the energy of this part. So half plus half, 1 into 1, it is 1. So energy of this part is 1. This is also 1. Symmetrical. This is also 1. It is a periodic signal going from minus infinity to infinity. So adding 1 up to infinity, we will get infinity, right?
Yes, ma'am.
So periodic signals have infinite energy. Is this clear?
Yes, ma'am.
Just now.
All periodic signals are not energy signals, as they have infinite energy, because infinite periods will add up and give me infinite energy, even if it's finite in one period, right?
Yes, ma'am.
Okay, now let us calculate energy of the following signal. Sigma n is equal to minus 2 to 1 rect of t minus nt. So here n is from minus 2 to 1, not from minus infinity to infinity. So we will get finite energy. So this signal, how will it look like? Let me quickly draw it. This is for n is equal to 0. For n is equal to 1, it will be centered around t. For n is equal to minus 1, it will be centered around minus t. N is equal to minus 2, it will be centered around t. Now let us calculate the energy of this part. So I'm calculating only the energy of this green portion. So what is the magnitude of this signal? Will anyone unmute and speak? What is the energy of this signal encircled in this green?
1.
1.
1 from minus half to half. 1 is magnitude, square of 1 is again 1. So I have 1 dt, and it is 1 in between minus half to half. If I do this integration, I get 1 right?
I think 3.
Yes, ma'am.
Yes, Jay, please repeat.
Ma'am, the limit is minus half to half.
All right, let me repeat my question. Right now, I am calculating energy of this signal, which is 1. This is rect of t. It is 1 and minus half to half, and outside this interval, rect t is 0, right?
Yes, ma'am.
So I am calculating energy of this rect of t. Is this energy of rect of t 1?
Yes, ma'am. But
J is
Yes, ma'am.
energy of rect t1. Now, these other three things are similar to this. They're symmetrical, like their magnitude and duration, everything is same.
Yes, ma'am.
So now, what did I erase? So now we know that energy of one of these is 1. Since there are 4 copies, so total energy will be
4.
1 plus 1 plus 1 4 times. So we will get 4. So this is the energy of this signal. Is this fine?
Yes, ma'am.
Okay, now let us move to power of signals. Okay, class, tell me, we have energy signals, we have power signals. Is it necessary that a signal has to be either energy signal or power signal, or is there any other category?
There is one
signal
category where
cannot be power or energy, right?
Yes, just like even or, we also have energy, power, or neither energy nor power. Now let us look at the definition of the power calculation. If I have a signal xt, this is how I will calculate its power. A power of signal xt is limit t tending to infinity 1 upon t integration from minus t by 2 to t by 2 mod of xt square dt. Now here one thing to note is, if here instead of t I take 2t, then here I can take minus t. So it is important to have the same width here. Is this clear?
Yes, ma'am.
yes, ma'am.
Okay. So after the definition, we can also say that power is average energy of signal, because this is kind of, if we put the limits here of t tending to infinity, then this becomes energy. We divide it by the period, so it is kind of like taking average. So we can say power is average energy of signal. Now we saw that if energy is less than infinity, it is an energy signal. And if we calculate the power of an energy signal, it will be 0. If power is greater than 0, that is, it is a power signal, then its energy will be infinite, just like a periodic signal. A periodic signal has infinite energy, but its power is finite. So, are these things clear from the lecture?
Yes, ma'am.
Signals with finite power are called power signals. Now let us take these signals, rect t, triangular of t, a raised to the power of minus t, but for t greater than 0. So can you tell me what will be the power of these signals? Class, will someone tell me the
Uh,
power of the? Yes,
for the
Ananya.
rectangular one, it will be 1.
The energy of the rectangular signal was 1, right?
Yes, ma'am. So the time period is Okay.
It does not have a time period. We will divide it by
Ma'am,
t, then we will apply the limit t tending to infinity. So we will essentially divide this 1 by infinity. So we will get 0.
Zero.
0.
Yes. So as we see, these rect t, triangular of t, or e raised to the power of minus t for t greater than 0, they all have finite energy. If they have finite energy, they are energy signals. So their power is 0. Is this clear, or you want me to show it mathematically? Ananya,
Clear.
is it clear?
Yes, ma'am.
Okay. Now let us take another example from the lecture. The asymmetric signal. -1 here, 0 here, 1 here, 1 here. So what is this is a finite length sequence, and its amplitude is also finite. So we can clearly see that it is an energy signal. So we can directly say that its power is 0. If we calculate energy of this signal, we will get it to be 4 by 3. Do you remember using this equation, this signal in the lectures? Now what I will do is, if I want to calculate power, I will divide this energy with the time, with this t, and I will set this t to infinity. So I will get 0. Is this clear?
Yes, ma'am.
So this, the power of this is 0. And now let us take this a sine omega t plus b sine vt. So these signals will be orthogonal. When will they be orthogonal?
When omega is not equals to.
Yes, so they will be orthogonal when omega is not equal to b. Do you remember you computed the energy of this kind of signal? What will it be? Sorry, power of these signals. These are periodic signals, so energy is infinite. We will talk about power. So what will be the power of this? Just take one of them. A sine omega t. What will be the power of this? Anyone?
A by 2.
You are slightly correct. So it is a square by 2. You can go back to the lectures and see the derivation again. It is a square by 2. So it is a result. You should remember that if you have any sinusoid, then the amplitude, you will take the amplitude, square it, and divide by 2. That will be the power of the sinusoid. And if I shift this sinusoid, my power will not change. And even if I change frequency also, na, my power will not change. Power will still stay a square by 2. So this has a square by 2. The power of this is b square by 2. So the total power of this signal will be a square plus b square by 2. So you should like remember this result so to quickly solve the problems. All right, is that fine?
Yes, ma'am.
Okay, now do you remember our good old unit step signal? What will be the power of unit step signal? So the power of unit step signal will be half. Do you want me to calculate it?
Yes, ma'am.
Okay. So let us go back to the definition of power signals. Px limit t tending to infinity. I will actually copy it from here. So let us do it. Limit t tending to infinity 1 by t. Ut is 1 in which interval? 0 to infinity, right?
Yes, ma'am.
Okay. Now ut is a real signal. So its magnitude is 1. What is 1 square? 1 again. Sorry, here I will take this t. It starts from 0, so I will take 0. But for the upper limit, I will take t. So you notice here it is t, and this here also interval is t. All right, is that fine?
Yes, ma'am.
Yes, ma'am.
Now I integrate limit t tending to infinity 1 by t. I will integrate and I will get t here, right?
Yes, ma'am. Not t by 2, I guess.
Yeah, no, wait. I think I've made some
The
mistake.
upper limit will be t by 2, same as in the expression.
Yes. Thank you, Jay. So here, lower limit will go to 0 because of this. Upper limit will stay t by 2. And now I will integrate. So limit t tending to infinity 1 by t. I will get t by 2. So now this t cancels with this t. So what we are left with is half. Is this clear?
Yes, ma'am.
Yes, ma'am.
So the power of unit step signal is half. Now let us take this signal e raised to the power of at. So this is lying between minus infinity to infinity, this signal. So uh, if it if irrespective of whether a is positive or negative, at one of the sides it will go to infinity. So my power will be infinity. So there are certain signals which are neither energy nor power signals. But if a, this is when a is positive or negative, but if a is is complex, let us say a is equal to j, then e raised to the power of jt, its power will be 1, but its energy will be infinity, it being a periodic signal. Is this fine?
Yes, ma'am.
This is clear now why power is 1, or should I calculate?
It's clear. We will solve it.
Okay. And anyways, this is easy. Magnitude is 1. So you will square it and then 1 by t and limit, and you will get it. Now let's move
Excuse me,
to
ma'am.
power. Yes.
For any periodic signal or the sinusoidal signal, to
Mm-hmm.
calculate power, we just divide with the magnitude, right? Here it is magnitude 1, 1 by 1 is all.
No, not for these signals. I said for sinusoidal signals.
Only for the sinusoid.
Yes. So there we will take the amplitude, square it, and divide by 2, irrespective of frequency or time shift, scaling or time shift.
But for the e to the power t, you also said the magnitude is 1.
This one,
E to the power 80. Yeah. E to the power jt.
e raised to the power of jt.
Yes.
Yes, magnitude is 1, but it has, that cos component and sine component, so kind of like two sinusoids.
Oh,
So it's better to use the power formula.
basically the it is e to e raised to the power gt. So we can write as in a sinusoid, right? In complex.
Yes, Yes.
Okay.
Okay, now let us move to power of periodic signals. When we talk about periodic signals, then power of periodic signals is average energy in one period. Power of periodic signals is average energy in one period. So E of x divided by t is what I said. When we talk about periodic signals, t will be finite, and we have this nice formula. And just like we discussed for periodic signals, energy in every period is same. For periodic signals, energy in every period is same. So power is average energy over time, we can say that. Just the last part of the theory, then we will move to problems. Power is average energy over time. And just to bring it to you one more time, if I have a signal xt and a signal x of at, that is the scaled version. So if power of x of t is p, power of x of at will also be p. Why is that? Because period will change. So overall that effect will lead to the same power. But if I have a signal xt, its energy is E, and I calculate the energy of x of at. So its energy will become E by mod A. Is this fine? Can we
Yes,
move to
ma'am.
problem solving now? Can we move to
Ma'am.
problem solving? Yes, Ananya?
Yes, ma'am.
Okay. So do you
Ma'am, I
want?
have a doubt.
Yes?
Ma'am, you say the energy signals. Ma'am, what about the sound signals? After some time, the sound signals also converts into energy signals. So, what is the difference between ma'am energy signals and sound signals?
Well, essentially, all our real life signals are kind of finite length, right?
No, ma'am. I am talking about the energy signals. Uh,
Yes.
uh, Sound signals, as we can say, just my name Gaurav. If I sound Gaurav, after
Hmm.
some time, the Gaurav sounds convert into a energy signals after a finite time. It will disappear.
When we say a energy when we say a signal is an energy signal, we mean that it has finite energy. So if you say anything, suppose Gaurav, so it is of finite duration. So if it is of finite duration, it is energy signal. So it is by default, by starting, it is energy signal.
Okay, ma'am.
Will you please ask your question again if it is not clear?
Yes, ma'am. Actually, I want to say the energy signal. If I spoken a Gaurav, if I
Hmm.
pronounce Gaurav,
Hmm.
after some time the Gaurav convert the word Gaurav, what
Hmm.
I pronounce the sound signals is
Hmm.
disappear and it's converted into a energy signal
Okay. What
because sound
exactly do you mean by energy
sound
signal?
sound signal never destroy, ma'am. I think.
I am not sure about that.
Okay, ma'am. Thank you. You can go
Gaurav,
ahead, ma'am.
maybe you can ask Professor Lakshmi. Do you have his email ID?
No, ma'am.
Okay. If you search na IIT Madras Professor Lakshmi Narasimhan, so you will probably get his email ID.
Okay, ma'am. Thank you, ma'am.
Okay, so in week 3 problem solving, do you want me to give you some time to solve the problem?
Yes,
Yes,
ma'am.
of
Yes,
course.
ma'am.
Okay. Week 3 problem solving. Okay, before I start, two things I want to tell. Derivative of even signal will be odd. Derivative of odd signal will be even. If we take example of cosine, cosine is even, derivative sine odd. Okay, so this is something I wanted to give you. Is this fine?
Yes, ma'am.
Okay, now I have the signal xt, which is sine of 2t plus 3. You have to tell me whether it is even, odd, or neither. How much time do you need? 1 minute is sufficient for this question. Is it class? 1 minute is
Yes,
fine.
ma'am, sufficient.
Okay. Okay, start. Done? Class, have you done?
Yes, ma'am, that neither.
Yes, it is neither even nor odd. So if we find x of minus t, replacing t by minus t, sine minus 2t plus 3, if I take minus common, this is what I have. The sine of minus theta is minus sine theta. So we can see that it is not equal to x of t, nor it is equal to minus x of t. So it is neither even nor odd. And we can also see it by that uh, combination of signals. So if we expand this, this is what we will get. Now this sine, cos 3, sine 3 are constants. Sine is an odd signal, cos is an even signal. Odd plus even will give me neither even nor odd. Okay, is that fine?
Ma'am, can you once explain it again?
The whole thing.
Yes, ma'am, just quick.
Okay, so xt is sine 2t plus 3. Now we come to, we will find x of minus t. So I will replace t by minus t. So I get this. Is this fine, Ananya?
Yes, ma'am.
Now I take minus common inside this angle. So I get this.
Yes, ma'am.
Sine of minus theta is minus sine theta. Right?
Yes, ma'am.
So this is what I finally have as x of minus t. Is it equal to xt?
No.
Is it equal to minus xt?
No.
So that means it is neither even nor odd. Now let us look at this. So sine 2t plus 3, sine of a plus b. I will use that trigonometric identity. Sine a cos b, sine b
Okay,
cos
ma'am, got
a.
it.
So this sine is odd, cos is even, so their sum will be neither even nor odd. Fine?
Yes, ma'am.
Okay, so for the next question, I will probably give you 5 minutes. Please try to solve. So you have the signal x of t is equal to u of t plus 4. You have to tell me the even and odd components of this signal. So you have to draw it graphically, and you also need to give me the analytical expression. So your time starts now, your 5 minutes. Is there
But
any
analytical expression means?
like this xt is equal to u of t plus 4. This is analytical expression. And if I draw this signal u of t plus 4, this is the graphical representation.
Oh, okay.
So you have to tell me graphical and analytical representation of even and odd parts of this signal. Okay, go ahead. So, I know you might have already started, but just to give you hint, we will use this formula. Even part is xt plus x of minus t by 2. Xt is ut plus 4. X minus t will be ut minus 4 divided by 2. You will draw these two signals and then add them and see what you get. And once you have the graphical representation, you can write the analytical representation. And the same for odd signal. Only thing, instead of plus, we will have minus here for the odd component.
Then
Yes?
is it the even one is starting from -4 and ending at 4, while the amplitude is 1 by 2?
No, no. You're close. Just quick observe it again. We are adding. Okay, class, do you want me
And
to?
it would
Yes?
1 by 2. DC signal.
1 by 2.
Well, for t is greater than 4, it is 1 by 2, and for t less than equal to 4, it is 1 by 2.
Yes.
1.
And what about in
Or
between?
in between, let's
Yes.
take 1 minute.
Okay.
In between, it is 1.
Yes, yes, you got it right, Jay. Very good. So I will. Do you want me to solve the even part, or you want me to wait for you to find out the odd part also? Class, what do you want?
So, ma'am, I will
And
find out.
What?
I will
You.
find odd pod also.
Okay, okay. Just 1 more minute, Jay. We are running out of time already.
then from minus infinity to -4, it is 1 by 2, and after that, uh, it will start from positive 4 to infinity, and it will be minus half.
You are telling about the odd part, Ananya.
Yes, ma'am.
Okay, so now that one of you have answered and we don't have that much of time, so I will
Ma'am,
now
ma'am, ma'am.
proceed.
Uh, for
Yes.
the for the odd part, for t greater than 0 it is half, and in between it is 0, and for t less than minus 4 it is, I think, minus 1 by 2.
Yeah.
Is it correct?
Yes. You
Oh,
actually, instead of 4, na, you said 0, otherwise, the rest of the things are correct. So now
uh,
I will start solving.
okay, okay.
So, my signal xt is u of t plus 4. This is u of t plus 4. And since we will be needing x of minus t will be u of minus t plus 4, just time reversal of xt. So I have my these two signals. Now I want to add them and then divide the amplitude by 2 to get the even part. So let us observe it. What happened? My screen is visible and am I audible?
Yes, ma'am.
Yes, ma'am.
Thank you. Okay, so this is x even of t. I want to add these two signals. So let us observe the time before minus 4. So before minus 4, the first signal is 0, right?
Yes, ma'am.
The second signal before minus 4, it is 1. So right now we are talking for less than minus 4. Less than minus 4, 0 plus 1 is 1. 1 divided by 2 is 0.5, right?
Yes, ma'am.
So we have 0.5. Now let us take 4. If I take 4, 4, so this first signal after 4 is 1. The second signal after 4 is 0. 1 plus 0 is 1. 1 divided by 2 is 0.5, right? Is this clear, class?
Yes, ma'am.
So this is 0.5. Now let us come between minus 4 to 4. Sorry.
And it will be minus 0.5, right?
Let us see. So between minus 4 to 4, we found before minus 4, after 4. Now between minus 4 to 4, first signal is 1, right?
Yes, ma'am.
Second signal is 1. 1
It will be
plus
0.
1. 1 plus 1 is 2. 2 divided by 2 is 1. Is it, class?
Yes, ma'am.
So now we have our even part. This is the even part that you guys got.
Yes, ma'am.
Yes, I'm doing the even part. Now let us write the analytical expression of this. So someone will tell me what expression would it be?
U t plus 4 minus u minus t plus 4 divided by 2.
Okay, slightly
For
correct.
the odd part.
We are now, right now doing the even part now. So for the even part, let us start from right hand side. So first let us write this signal. What will it be? Magnitude is half u
When
of
t is greater
t
than
minus 4. Is this fine for this signal, this expression? Everyone agrees?
Yes.
All right. Now let us write for this part. For this part, It is actually the time reversed version of what we wrote here. So we will simply write that
half ut
half
plus
u minus t minus 4. What about the middle part? Do you see this middle part? Does it sound familiar?
rect.
Yes, this is rect. So what is my rect signal? So I told you to remember na A rect t by tau. Do you remember that?
Yes, ma'am.
A tau by 2 minus tau by 2. So A we can see it is 1. Tau by 2 is 4. So that gives me a value of tau to be 8. Right?
Yes, ma'am.
So this is my signal. Is this clear?
Yes, ma'am.
Okay, now let us move to the odd part. So for odd, it is x of t minus x of minus t divided by 2. X of t is ut plus 4 minus x of minus t divided by 2. I will copy these signals. So since we are doing subtraction, so for the second signal, we will just take the time reversal. This is first signal. So can you see this second signal over here, x of minus t?
Yes, ma'am.
Now if we do the amplitude reversal, so this is what it will look like. Basically 1 will become minus 1, right?
Yes, ma'am.
So I will draw that here for the odd part. This is minus u of minus t plus 4. This is how it will look like. Now, since I have already taken the amplitude reversal, so we just have to add these two signals and divide by 2. You guys got the answer and that's really good. So now let us do it together. I want to add these signals. Let us consider the part which is after 4. So after 4, first signal is 1, the second signal is 0, right?
Yes, ma'am.
1 plus 0 is 1. 1 divided by 2 is 0.5. So we have 0.5 here after 4. And since you know it is an odd signal, so you can take that image about origin also. But let us just solve it also. Now, between minus 4 to 4, this is 1 and this is minus 1. 1 minus 1 will give me 0, right?
Yes, ma'am.
So this is the middle portion, which is 0 till minus 4. Now after minus 4, before minus 4, I mean this portion for first signal is 0. For the second signal, this is minus 1. 0 minus 1 is minus 1. Minus 1 divided by 2 is minus 0.5. Right? Is
Yes,
this
ma'am.
clear? So we have this. Now if we want to write it down analytically, so x odd of t, let us first write this part on the right hand side. So it is just similar to what we wrote for the even one, right? It is same. So amplitude is half u of t minus 4. Is this fine?
Yes, ma'am.
Now look at the left hand portion, this one. So this is the time reversed version of the one on right hand side, and also there is amplitude reversal. So what I have is minus half u of minus t minus 4. Is this clear?
Yes, ma'am.
Okay, now let us move to the next question. I'm writing down the question. Let the power of signal xt is equal to 10 e raised to the power of j to t be p. The power of this signal is p. The fundamental time period of xt is t. So you have to tell me the product p into t. Is the question clear? Class,
Yes,
is the
ma'am.
question? Okay, so I will give you 3 minutes. Do it. I'm writing down the power formula here. If anyone gets the answer, please unmute and speak.
Ma'am, infinity.
Power you're getting as infinity.
Yes, ma'am. I
Okay, maybe we can take more questions on finding out power. Power is not infinity. If you see this signal e raised to the power of j to t, it is a periodic signal, so it will have a finite power.
Ma'am, its fundamental period is I think pi.
Yes. Okay, now time's up. Let me solve it, please. We don't have that much of time. Only 20 minutes left. Shall I solve it?
yes, ma'am.
Okay. So first we will
Yeah,
calculate
ma'am, go ahead.
power. Sorry.
Yes, ma'am, continue. You can solve.
Okay, so the power formula I've written, limit t tending to infinity 1 upon 2t integration minus t to t mod of xt square dt. I will do it step by step. Okay. Signal is xt is equal to 10 e raised to the power of j to t. So what is the magnitude of xt?
10.
Ananya, are you sure about
Yes,
this? That the magnitude is 10?
yes, ma'am.
So I will do 10 square dt.
Okay, ma'am. Ma'am, I took that e to the power j to t
Ma'am,
also.
power is 100
Yes,
and time period is pi. So
yes,
the
yes, you
answer
got
will
it
be
now.
100 pi.
Yes, so I'll just very quickly solve it. If you want me to repeat any step, please let me know. So power is 100. I took the magnitude 10, I squared it, then I integrate, I get T, 100 comes out. And so this power calculation, everyone is clear with this?
Yes, ma'am. When we're starting at that E part also, that's why it was right.
Yeah, it is a complex signal. So when we have a complex signal, we will take magnitude. For real signals, though, magnitude is same, but for complex, it is not.
Okay, ma'am, got it.
Okay, now let us calculate the time period. 10 e raised to the power of j 2t. Omega is 2. 2 pi divided by 2 will give me pi. So time period is pi. Is this fine?
Yes, ma'am.
3.1416. I will multiply power and time 100 into 3.1416. So 314.16. This is the final answer. Is this fine?
Yes, ma'am. Then in energy signals, we also take magnitude in that also.
Yes, yes.
Okay.
So in formula for both energy and power, we take the magnitude and then square the magnitude. If it is real, the signal will be squared. But if it is complex, you have to calculate the magnitude and then square it.
Okay, ma'am, got it.
Okay, now next question. You have to tell me. Okay, first of all, tell me. I have this signal cos 28 pi t ut. Is it a periodic signal or is it aperiodic?
Neither.
When we talk about periodic and aperiodic signals, a signal will either be periodic or it will be aperiodic. That is not periodic. So in periodic, we only have these two, either periodic or aperiodic. Is it fine, Jay?
Yes, ma'am.
It is clear now that in periodic, either it will be repeating or it will not repeat. If it repeats, it is periodic. If it does not repeat, it is aperiodic. Okay.
Okay.
Okay, so tell me, is this periodic or aperiodic?
A periodic.
Yes, it is aperiodic. Why is that? Because we multiplied this cosine would have been periodic, but we multiplied it by ut. So it exists from 0 to infinity. That is why it has become periodic. Now I want you to tell me the period of the following signal. Signal is even of cos 28 pi t ut. So this is the signal. You first check whether it is periodic or aperiodic, and if you find that it is periodic, tell me the time period of this signal. Is the question clear?
Yes, ma'am.
Okay. So I will give you 4 minutes. Please start. This is the formula to calculate even part of a signal. Once you're done, please unmute and speak your answer.
It will be minus infinity to infinity, and the magnitude would be 0.5 and time period 1 by 40.
Your final answer is correct, but a few of the things need to be. I will clarify that. So this is the signal. Okay, class, can I start solving now? Class, please
Okay,
answer.
ma'am.
Yes, ma'am.
All right. So xt here is cos 28 pi t ut, and this we have to find the even part of this signal. So how do we find even part? Xt plus x of minus t divided by 2. So let us do that. Xt cos 28 pi t ut plus, when this is time reversal, t is replaced by minus t. So although cos of minus theta is cos theta, but I'm still writing it again so that you don't face any confusion. So this is how we will be calculating even part. Cos 28 pi t ut plus cos 28. So here I have used that cos of minus theta is cos theta. Is that fine? This step is
Yes,
clear
ma'am.
to everyone now?
Yes, ma'am.
Okay, so we will now take out cos 28 pi t divided by 2 common. What I have left is ut plus u of minus t. So let us quickly draw it and see what will we have. What is this? Tell me. Ut, right? This is u minus t. Is this clear?
Yes,
This step is clear, this one?
yes, ma'am.
Okay. Now we have this thing in the bracket, ut plus u minus t. That I have drawn here. The first one is ut. The second one is u minus t. When we add them, what will we get?
A DC signal.
Yes, a DC signal with this amplitude of 1. So that means even part of the signal is, this is 1 in the bracket, so cos 28 pi t divided by 2. This is clear how we calculated the even part.
Yes, ma'am.
So now we have this even part. Is it periodic? Yes, because it is a sinusoid, cosine signal. Omega naught is 28 pi, time period 2 pi divided by 28 pi, basically 2 pi by omega naught. So 1 by 14 seconds. Is this clear?
Yes, ma'am.
So Ananya,
Yes, I
yours.
have got the same.
Sorry.
I got the same. Just
Yeah.
I multiplied that cos signal with that also.
Yeah, so the magnitude will actually vary with time. It is not a constant magnitude, and the magnitude will be cos 28 pi t divided by 2, and the time period is 1 by 14 seconds. Okay.
Yes, ma'am.
Okay, so I will just give you a very easy question, just 1 minute to answer, and then we will calculate power of another signal. So xt is t square plus t plus 1. Tell me the even and odd parts of the signal. You have 1 minute and your time starts now.
T square.
T square is what?
Even. Sorry. Odd.
T square is odd.
Yes, ma'am.
Check.
Ma'am,
T
I
square
have a
plus T
doubt.
is even.
Yes, Jay, ask your doubt.
Ma'am, I don't have doubt. I am telling the answer. The even part is t square plus 1.
Yes, even part is t square plus 1 and the odd part is the leftover thing t. Who had a doubt?
Ma'am, I have a doubt in the last question.
Yes, yes, tell me.
Ma'am, one thing I am unable to understand in the last question,
This
how
one.
the yeah, ma'am, the last one, cos of 28 pi t and u of
Yes,
t.
yes.
Ma'am, how the signals is defined here, ma'am?
How the signal is defined?
Yes, ma'am.
The signal
Because
x.
the
The
cosine
signal
cosine
x.
is the ma'am, the cosine is a even function,
Hmm.
and u of t neither odd or not even.
Hmm.
Then how the signal is defined, ma'am?
Well, see, the signal is cos 28 pi t ut. So cos 28 pi t will be something like this. It
Yes, ma'am,
will
even.
it will actually be like this, right? Extending from minus infinity to infinity.
Yes, ma'am.
But what did I do? I multiplied it by ut. So if I multiply with ut, it will start from 0, right? And go on till infinity. So this is the signal that I will have cos 28 pi t into ut. Does that answer your question?
No, ma'am.
What is your confusion? This signal, the analytical signal is this, the graphical one is this.
Ma'am, the doubt is, as we know the definition of unit step function,
Hmm.
it here it behaves for both positive and here it behaves for both positive and negative time. The
What?
even part of, ma'am, the cosine function
Hmm.
is symmetric around y-axis,
Hmm.
and the calculation, analytical calculation, ma'am, because I go
Cosine
through the
Cosine is symmetric, cosine is even, but when we multiply with ut, this is what we have. Now we want to know whether it is periodic or aperiodic. If it is periodic, this signal is aperiodic, but this even part, that is periodic, and we want to calculate the time period of that. I think I'm not able to understand your question.
okay, ma'am, let me think what is. Go on,
So,
ma'am. You can continue, ma'am. I
will
cross
you?
check my question.
Okay, maybe you can stay back after the session and then you can ask.
Yes, ma'am.
Okay, so for this signal, Jay's answer was right. So here now, instead of doing this, that x even of t is xt plus x of minus t divided by 2, since it is a simple signal, so you can, simply check. Like if you see this t, if I take this t, xt is equal to t, then I find xt is like of minus t, so it is minus t minus xt. So we can like very clearly see that this is odd. So the leftover portion has to be even because this xt is neither even nor odd. If some of the part is odd, then the remaining part has to be even, because a signal can be written as xt is equal to x even of t plus x odd of t. Is this clear or you want me to repeat it?
Ma'am, so we can also take as odd for t plus 1.
If we take odd part as
T
t
plus 1.
plus 1, then I will do x of minus t. I will get minus t
Oh,
plus
it
1.
will be neither.
Yes, because so I just checked that this t is odd. So x odd of t is t. The remaining portion has to be even because we can see that xt is neither even nor odd. Is this clear?
Yes, ma'am.
We are running out of time. Okay, let us do this question and then we'll see if we can do more questions or not. So I'm giving you the graphical representation this time. I will also give you the analytical representation, and I want you to find the power of this signal. So it is 4 from minus infinity to 0. At 0, it is this decaying exponential, which is 4 e raised to the power of minus 4t. You have to calculate the power of this signal. So how much time do you need? 3 minutes, is that fine?
Okay.
Okay, then you have 3 minutes, start. If anyone gets the answer, please unmute and tell me your answer.
Ma'am, is it 32?
Power 32.
Yes, ma'am.
Ma'am, I think the power is 0.
No, it is not 0. Use the formula. I will write the formula. Power is limit t tending to infinity 1 by 2t integration from minus t to t mod of xt squared dt. You will have to break it down at 0.
Power is 8.
Yes, Jay, your answer is correct. So now that one person has got, I will start solving. So my signal is this xt, which is 4 from minus infinity to 0. Then 0, we have this decaying exponential 4 e raised to the power of minus 4t. Ananya, this is an even signal. See, do you see any complex part here?
Ma'am, I wrote it as 4 plus 4 e to the power minus 4t. Is it wrong?
That is fine, but
There
you
will
have
be
to.
split from infinity to from 0 to t. It is no.
Yes,
Uh,
Jay, you're right. Let
from
me explain.
from minus t to 0, it is 4, magnitude of 4 square, and the second part is 4 e to the power raised to the whole square.
Oh, okay. Got it.
So this is the formula. Now let us break the integral since there are two different signals. So from minus t to 0, xt is 4. So magnitude is 4, 4 squared. So I will take 4 square dt plus 0 to t. Then from 0, the signal becomes 4 e raised to the power of minus 4t. So I will square this 4 e raised to the power of minus 4t square dt. This step is clear?
Yes, ma'am.
Okay, now let us solve it further. 16 comes out of the integral. We are left with this. Then here 16 comes out. We are sorry. Yeah. So we are left with this minus 8t dt 0 to t. This is clear? This step?
Yes, ma'am.
Okay. Now let us find the integrals. So this first integral will give me t, right? Capital T. Now the second integral. Oh, I'm sorry, I missed the minus sign. So e raised to the power of minus 8t divided by minus 8, 0 to t. This is fine.
Yes, ma'am.
Okay. So limit t tending to infinity 1 upon 2t into 16t.
Ma'am, in that e to the power minus 8t, so now we will take that as magnitude.
If it would have been j, then it would have been exponential signal.
Oh, okay.
But there is no j, so we will just square it. So
Okay.
4 square e raised to the power of minus 4t square. In exponents, the power will get multiplied. So this is what we will get, right? Is this fine?
Yes, ma'am.
Okay, so now let us get back to this step and then let's calculate the integral. So 16, then I will put the limit as t e raised to the power of minus 8t. 0 will give me 1. So this is what I have. Oh, I'm sorry, I missed this term. Okay, this is fine. Is this step fine?
Yes, ma'am.
Okay, so here the t cancels and we are left with 8. What happens to the second part? So if I substitute t with infinity, e raised to the power of minus infinity, so this will go to 0. But here this capital T is there, which is going to infinity. So a finite number divided by infinity will be 0, right? Is this fine? Should
Yes,
I?
ma'am.
So the second term is 0. So we are left with 8. So the power is 8. Is this fine?
Yes, ma'am.
Okay, Ananya, I want you to pay attention to this. When we talk about e raised to the power of j 80, it will be cos 80 plus j sine 80. Now we want to calculate the magnitude. So what will we do? Real part square plus imaginary part square under root. This is how we find the magnitude of a complex number, right?
Yes, ma'am.
Cos square theta plus sine square theta is 1. So this is 1. So in general, if we have a Euler signal, which is like this, then its magnitude will be this quantity and phase will be this quantity. Is this clear, Ananya?
Yes, ma'am.
But what happens if I have e raised to the power of 80? It is not a complex signal. It is a real signal as it is. So if we talk about magnitude of this signal, it will be this only.
Okay, ma'am. Got it.
I hope that clears your confusion.
Yes, ma'am. Yes, ma'am.
So can we take few more questions?
Sure, ma'am.
Okay, so I told you about the DC term and its periodicity. Now tell me the signal xt, which is cos square 2t, is it periodic? And if it is periodic, what is its period? Tell me, you have 2 minutes.
T is equals to pi.
It's actually
Pi by 2.
yes, Jay, you are right. Okay, so now let us solve it. So this is the formula of this cos 2 theta. Cos 2 Theta is 2 cos square theta minus 1. So cos square theta is 1 plus cos 2 theta by 2. You know this formula.
Yes, ma'am.
Now let us apply it to xt. Xt is cos square 2t. Theta is 2t here. Half plus 2 theta 4t. This is what xt will be, right?
Yes, ma'am.
So this first thing is a DC signal. So it has arbitrary period and it does not affect periodicity. So the period will be the period of this signal. So for this, omega naught is 4, t is 2 pi by omega naught, 2 pi divided by 4. So it is pi by 2 seconds. Is this fine?
Yes, ma'am. I forgot to change that 2 into 4.
Okay, so you should not directly calculate for square things, because what I said was for cos theta, right? That it will be a square by 2. Oh, sorry, that was power. For period, you have to do this. If the signals... Okay, shall I proceed?
Yes, ma'am.
Ma'am,
Yes.
right now we are calculating average power, I think.
We are calculating period in this particular question.
No, ma'am, about power.
Yeah, power, yes.
Average power, I think. We are calculating average power. We are using the average power formula.
Yes.
And ma'am, what about the instantaneous power?
Instantaneous power. Well, I don't know. I'll try to find the answer and then get back to you.
Okay, ma'am.
Okay, now another quick question. This signal xt is 8 cos 20 pi t minus pi by 2 plus 4 sine 15 pi t. Tell me the power of this signal xt. Quickly do it. Just 1 minute. Gaurav, are you solving these questions?
Yes, ma'am.
Okay.
Last time I made a mistake in the last step.
Mhm. Are you guys done?
40, ma'am?
40?
Yes.
Yes, that's correct. So what we need to see here is, this is a cosine, this is another cosine. Time scaling and time shifting does not affect power. So what we will do, also these signals are orthogonal. So power of a cosine is amplitude squared divided by 2. These are two orthogonal signals. So just the power will add up. So 8 square by 2 plus 4 square by 2. 32 plus 8 is 40. Is this fine?
Yes, ma'am.
Okay, now one problem on energy. Shall we continue?
Yes, ma'am.
Okay. So you have this signal x1 of t, which is e raised to the power of minus t ut. The energy of this signal is E1. You have another signal x2t, which is e raised to the power of minus 3t minus 1 ut. Energy of this signal is E2. So you have to tell me E1 into E2. You can use the calculator. 4 minutes, is that fine? Or do you need more time? Actually, we are already out of time now. 4 minutes, is that fine? Okay, take 4 minutes. Try to solve this question. I will write the energy formula here. Even if anyone gets na E1 or E2, you can unmute and tell me the values of E1 and E2.
E1 is half.
Yes, that's correct.
Ma'am, E2 is E square by 6. Am I right?
Yes, you're right. Okay, so Jay, you got the answer. So now, can I please start solving others? Can I please start? Others apart from Jay? Or you need 2 more minutes? Should I start solving?
Yes,
Yes.
ma'am, you can start.
Okay, so x1t is e raised to the power of minus tut. Energy formula minus infinity to infinity mod xt square dt. x1t is a raised to the power of minus tut dt. Ut makes the signal causal, so it starts from 0, 0 to infinity. E raised to the power of minus t square, so the powers multiply, so I get e raised to the power of minus 2t. So this is the integral that I have, e raised to the power of minus 2t dt, 0 to infinity. I integrate and I get half. Is this fine?
Yes, ma'am.
Okay, now let us calculate E2. So E2 is e raised to the power of minus 3t minus 1 square. So power will be multiplied by 2. Ut will make it from 0 to infinity dt. Is this expression for E2 fine?
Yes, ma'am.
Others
Yes.
also? So I can write it as this, e raised to the power of minus 60, and e square will come outside, it being a constant. Sorry, my screen is visible now.
Yes, ma'am.
Okay, so if we calculate this integral, e square e raised to the power of minus 60 divided by minus 6, 0 to infinity, so we will get e square by 6. Is this fine?
Yes, ma'am.
Now E1 into E2 is half into E square by 6. So we get E square by 12. If you find the value of E square from calculator, it will be 7.39. So your final answer will be this. Is this fine?
Yes, ma'am.
Okay, now let's quickly, just three very minor questions of conjugate symmetry and conjugate asymmetry. So let us do that also. My signal zt is e raised to the power of jt. You have to tell me whether it is conjugate symmetric or conjugate asymmetric or neither. So in fact, for all of these three questions, you have to tell me the same.
Conjugate symmetry.
Yes, it is conjugate symmetric. So how do we do it? Let us quickly do it. We will find the conjugate. Now, once we have the conjugate, we will take time reversal. For conjugate, j is replaced by minus j. For reversal, t is replaced by minus t. We get back the same signal. So this is the definition for conjugate symmetric. Is this clear? Is this clear now?
Ma'am,
Yes,
a
ma'am.
small doubt.
Yes?
we can either do first minus t, then conjugate, or conjugate then minus t. This is imply to all the signals, right? We can
Yes,
do
yes,
either.
you can do in any order.
Okay, okay. The order is not required. Not necessary whether we can do first conjugate then reversal, right?
Yes. So now I want you to see that zt is cos t plus j sin t. So cos t is even, sin t, this thing is even, this is odd. So this will produce a neither even nor odd signal. So you should note that even though this zt is conjugate symmetric, but it is neither even nor odd. Okay? Class, this is fine now?
Yes, ma'am.
Okay, now another quick question. Zt is j e raised to the power of jt. Tell me whether it is conjugate symmetric or asymmetric. Yes, anyone wants to answer?
Symmetric.
What?
Symmetric.
No, it's asymmetric. So let us do it. Zt is e raised to the power of, sorry, zt is j into e raised to the power of jt. So let us this time do reversal first. So j e raised to the power of minus jt. Now let us take the conjugate. So when we take conjugate, j's will change into minus j. So this is what we will get. Is this fine? This step is fine.
Yes.
Yes.
So what we get is z star of t is minus zt. So this is the condition for conjugate asymmetric, right? If it would have been equal to zt, then it would have been conjugate. Sorry, conjugate symmetric, but it is conjugate asymmetric. This is fine.
Yes, ma'am.
Now I also want you to look at this expansion. So zt is j e raised to the power of jt. I write this Euler signal in terms of cos and sine. I multiply by j, and this is what I get, right? Is this fine?
Yes, ma'am.
Now this is odd and this is even. So again, it is neither even nor odd. And what I want you to focus on is that this first signal was conjugate symmetric, and we studied that for conjugate symmetric, the real part is even and the imaginary part is odd. So that follows, right?
Yes, ma'am.
Now let us look at this conjugate asymmetric signal. Here the real part is odd and imaginary part is even, just like what we discussed, right?
Yes, ma'am.
Okay, now this is the last one. So zt is t e raised to the power of jt. Tell me whether it is conjugate symmetric or conjugate asymmetric.
Conjugate symmetric.
No, no, it is asymmetric. Let's do it.
Okay.
So
Yes, ma'am.
z,
I got asymmetric.
yes, yes. So it is conjugate asymmetric. How do we do it? Zt is t e raised to the power of jt. So let us first do time reversal. T is replaced by minus t. Now we will take the conjugate. So this stays as it is. J turns to minus j. So this is what we have, and it is equal to minus zt. Right? Is this fine? Are you following?
Yes, ma'am.
So this is conjugate asymmetric. Now if we decompose it like this, then notice that this is odd and this is even. T is odd, cos is even. T is odd, sine is also odd. odd into even, odd into odd, even. So here also we see that the real part is odd and imaginary part is even for conjugate asymmetric signal. Is this fine?
Yes, ma'am.
Yeah, so that's all I had to discuss. Do you have any questions?
No, ma'am.
Okay, I will just stop the streaming and then we can discuss Gaurav's doubt.